Greeting students. I hope everybody are all fine and healthy in this health crisis as well. Today we are going to discuss the 5th week revision of Python module. So let's get into the topic without getting it in late further. Now we are going to enter into the week 5 revision of Python module. Today we'll be discussing as many topics as that are covered in week 5. Now the very first topic is what is a function and how do we define a function. A function is a block of code which only runs when it is called. Basically we just define a function according to the desired output, and we define a function only when there is no particular one which comes predefined along with Python. So we can pass data which is also known as parameter into a function. This is the general point is that a function is defined using the def, which is the def keyword. Def is a keyword and it is used for defining a new function which doesn't exist or which isn't predefined with Python. A function can return a data as result. We see that here the output of this particular defined function, which is area, is a value, but we are printing this value with the help of print command, whereas in some functions there need not be any written or a print value, or in either ways a function could have multiple parameters or no parameters. Now let us consider defining a basic example of function. In this case, now we are defining the first function, which is a very introductory part of this week. Define area LB. Here L stands for length and B stands for breadth. And now we assign a variable ans answer, which is equal to the product of length and breadth. And now we print the answer, which is the required one by the user. We can run this. So thereafter, after running this, we need to assign values to L and B. Let us say length is 20 and breadth is 30, and now we need to call the print, and now we need to call the function here which is predefined above, area of LB. And now let's run this to see the result. Yes, we see that it is 600. Let us manually check that 20 into 30, 2 into 3 is 6, and 6 into 100 is 100. Therefore the answer is verified. Hence we had successfully defined a function called area that consists of 2 parameters. And now we are done with the basic understanding of a function. Now this is the second function that we are going to define now. Define add a comma b. Now in this function we are going to add 2 quantities or 2 variables a and b and assign it to a value an as answer. And this is same as the above example. And now we assign a values of, the most important step is that we need to execute the function that has been defined in order to use it or in order to make a call in the upcoming lines of code. Let us assign a value of a to be 20 and b to be 30. Now let us run this. Yes, we see that it's 50, and hence we are successful in defining the function which is called add, and it also consists of 2 parameters a and b. the basic property of a defining function is that a user defined function consists of name of function. Here we see that add is the name of function here. Add is the name of function, and parameters, we see that a and b are the parameters. This is the basic structure of a function. The body of a function is ans. These two lines are the body of a function, and these complete three lines are all together the definition or the defined part of a function. And next we make a call here. This particular line is called call of this function, and a comma b, these are the values. We call them to be as values, or we call them to be as arguments as well. A brief description of a function has been given in the notes that is present in the link below. You can access that for better understanding. Now let's move to the further case, which is very important. In order to make further calculations or operations, we should not use print statement, as it throws an error. Using a print statement throws an error. If we want to make further calculations, we should not use print statement, and we need to use only return statement, because here we are consider this particular function. In this function, this function is defined only to print the answer but not to return the answer to the user. And if we try adding say 10 to the print answer plus 10, it throws us an error. And now there is another important point to be noted. From a function's perspective, a parameter is a variable. These two are the parameters. A parameter is a variable. Here L and B are the variables listed inside the parenthesis defined in the function definition. As these both are present inside the parenthesis, both L and B are considered to be as the parameters. And an argument, as discussed now, these two 20 and 30 are the arguments here, and an argument is the value that is sent to the function when it is called. Here we are calling the function add by giving the values 20 and 30 to a and b respectively. Hence 20 and 30 are called as arguments of this function called add. And now we are done with the first part of this week. And another important point is that the difference between return and print keywords. To let a value or to let a function return a value, we use the return statement. To let a function return a value, use the return statement. Now let us run this as well with a different variable, and make sure that we define it after updating with return statement. And let us change the variables now. Let length be 10 and breadth be 20, and let me run this 200. We see that the answer has been written as 200. This returns the answer, and we can make further calculations to this 200. Now a print statement. Now coming to the print keyword. To print output without returning its value to the console, we should use the print statement. Syntax error, we are missing the parenthesis. Yeah, that's a point to be noted. And it's common that we need to be having a good state of mind for any programmer. We need to have good state of mind to avoid making mistakes in any examinations as well. We had updated the return with print, and now let's check for the same values. Yes, it's working for the same values and it's returning 200 as well. Now examples of functions. Let us discuss some examples of functions which are frequently asked in any competitives as well as interviews as well. The minimum element in a list, or the minimum element of a list. We define a list. We define a function called list underscore minimum. Here L is a parameter here. Since it's inside the parenthesis, L is considered to be a parameter, and the name of function is list min. We start with defining or assigning the value of the first element of the list to be as the minimum here, and we call that as min. Min is equal to the element present at the 0th index, which is the first element, for I in range length of L. Here the length of L refers to the total number of elements present inside the list, whether it can be somewhere around 5, 10 or then n. Let it be n. If L of I is less than min, if L of I is less than min, the value of min is the element present at the 0th index, and if in any case we find that Li is less than minimum, then we update the value of min with L of I, that is with the element present at the ith index, and we return the minimum value. And to check this out, let us do a small check. L is equal to let us give some random numbers: 23, 67, 34, 56, 87, some random number: 21, 98, 89, 789, 45. I typed whatever I got random to my hand, and now we should call the function that has been defined above. List min L. Let us say this is A. Now this is also A. We see that this code has been run successfully. The smallest element in this given list is 21, and it has been written. And please make this a note, students. We had defined the function to be as L, and it considers anything that has been defined with the list here. Here we had defined the list with A, and it is not mandatory to be that the name of list should be L, or the list should be indicated with L only. It can be A, it can be Z, it can be M, something else. But the function gets executed perfectly. There is no such mandatory condition to be satisfied. Now let's move to the second example: maximum element in a list. What we do is that we just change a single value, which is min. You can see the same difference, students. We had given the max here. Max is equal to the element at the 0th index, which is the first element. We generally assume that the first element, because we cannot take any other element because we don't know the range of how many elements are present in the list. Hence we take the very first element and consider it to be the maximum or minimum respectively, according to the situation. Now for I in range length of L, yes, it is the same again. As we dealt with the minimum value earlier, now we deal with the maximum value. The sign must be changed. Now if the element present at ith index is greater than max, which is the element present at 0th index, that is first element, we update it with element present at ith index and return the maximum element. Now let us execute this as well. Let us give the same list here as well, and let's call the function 789. Yes, we find that it's 789. Yes, it's running perfectly, there's no mistake. We are successful in defining this function to append two lists. In this append two lists, we can do in either format, and we can append A first and B next, and B first and A next. Both cases can be done with this single code. Now let's see how we can do that. Define append two lists. Append lists is the name of function. A and B parameters, or the A and B are the parameters which instead are lists here. Firstly, we need to create an empty list. We need to create an empty list C to append the elements to it and represent it as a single array, single list, because we are appending two lists, the appending of two lists results in a new list, or it is completely a set of two lists. Hence we are defining a new list here, which is C. For I in range length of A, C dot append A present at ith index. For this we first append the elements of A here to C. Until the value of I is completed, we keep on appending the elements present at ith index, and then we move on to the next for loop, which adds the elements of list B to the list C, which is the new list. And after completing the values of I here as well, in the case of B, we return the array, we return the list C. Let us try out this as well. Let us say A is equal to 1 2 3, B is equal to 4 5 6, and now it's time to get into action, students. Append lists A comma B. Yes, we are successful, hooray. 1 2 3 4 5 6, yeah. And now let's interchange now. Now earlier we saw that the elements of A were in the leading position. Now what do you expect to happen, students? We need to run this again as we change the values. Yes, as I said earlier, this single code is enough to just add two lists in either ways. You just need to interchange this according to the question that has been asked in the paper. Yes, we are successful in creating two different functions from a single piece of code. Hence this is an important step to be noted, to that ease of code is maintained. Average of elements present in a list. Yes, this is the same again. We initialize the sum of a list to be 0 because we did not add any elements. This is the main point, students. We did not sum up any elements of a list, and hence it is 0 in the very beginning. For I in range length of x. Yes, sum is equal to sum plus element at ith index. As this is 0, 0 plus element at ith index, let I be 1. If I is 1, 0 plus 1, 1, and that's the first, and that's the new and that is the new value that we are updating to sum. And after all the elements are completed in X, we assign the answer to be as ANS is equal to sum by length of X, as this is the general formula for calculating average. The mathematical formula for calculating average is sum of total observations by total observations. And now we return the answer. Let us try doing this as well. Let us say what's that, A is equal to 1 2 3 4 5 6 7 8 9 10. Oh sorry. Now average list of A, we are calling this. Yes, we see that the average of first 10 natural numbers are 5.5. Let us calculate this manually as well in order to cross check. 1 plus 2 plus 3 plus 4 plus 5 plus 6 8 plus 9 plus 10 by 10. We need to print this. Oh, this has been something unexpected. Yes, we see that it's 5.5 again, hence we are successfully done. Once a function is declared, it can be called at any point of time in the flow of a program. Now friends, see, now we had given the list to be as A, 1 2 3, 1 over the numbers from 1 to 10, and we had only called the average list. And now let's call, and now let's try to call the predefined lists by us, predefined functions by us earlier. Let's say we want to call the minimum list function of A and list maximum A, and what's the other one that we defined? Yes, these are the two. We are printing 10 because the latest command present in this is the maximum element. And now let's remove this and try executing this now. 1. Yes, the least element is 1. And the third topic is sorting using functions. The passing a list as an argument is the primary step in sorting a list. Generally, you can send any data type of argument to a function. The argument can be a string, number, list, dictionary, anything, and it will be treated as the same data type inside the function as well. Creating a new list, appending elements to it, and removing the same elements from the old list are the important fields to take care of. Appropriate loop has to be chosen at the time of specifying the condition prior to sorting. There are 3 loops which are learned by us: while, for, if else. And then user can call a function once it has been defined in the earlier stages. This is much helpful in sorting in sorting a list using functions. Following the above step, following the earlier step, that we can call a function that has been defined earlier is very much helpful, because it helps us in reducing the length of a code, which indeed saves the time and complexity of code. The steps in sorting a list are: find out the minimum element in the list, because we need to sort it ascendingly or in ascending order. Append that to a new list. We need to create a new list as done earlier above, like this, in appending to lists. Remove the minimum element from the original list or old list. Yes, these are the main three important steps. And now we come to define sorting a list function, and the define sort list is the name of function is sort list, and as discussed now, new list has to be created, which is an empty list. This is the new list into which we append the elements of the list A, while the length of A is greater than 0. We cannot use if, because if length of A is greater than 0, what happens if we use if? The thing that happens if we use if is, if length is greater than 0, then we start executing this, and whenever we move on to the same condition, while length of A is greater than 0, that is, it's a non-zero list, we move on considering the elements to be present inside the list. If the length of A is not greater than 0, then the loop gets terminated, where the answer might reverse the wrong one. Hence we are using a while loop here. Minimum is equal to the element. Yes, we do the same. Minimum element of a list, we do the same function here. Minimum, we update that with the element present at the ith index. The thing that we do is append that to a new list. Yes, B is the new list here. We had appended the minimum element to the new list, and we had removed the minimum element from the original list using the remove one. A dot remove min removes the minimum element from the list A, and B dot append min appends the minimum element to the list B. And after following the particular steps, a list gets created and the original list gets becomes an empty list. Now let's call this function. A is equal to 45, 65, 74, 23, sorry, 45 has been repeated, 47, 12, 9. This is the list that we have taken. Now sort list A. Yes, we see that the list has been sorted in ascending order. 9, yes, 9, 12, 23. Is there any number less than 23? No. 45, yes, 45, 47, 65, 74. Yes, we have perfected this. Hence we had done this perfectly. And now doing the same operation with the help of functions that are defined by us earlier. Instead of writing the entire minimum, we can directly use the function that has been defined by us earlier, which is list minimum L. Now, as I said earlier, sort list B, we are replacing this entire part. We are replacing this entire 3 lines with a single line. We are assigning the minimum value to be that stored in the function that has been defined above. Here the list min is 21. It holds a value of 21 here, and the same is applicable here as well. It internally when we call this function, it goes up all here and refers to this function and calls it and internally makes all the process done and brings out the least element and adds that to the list B, and that's it. We are done. Oh no, I was in a hurry. Yeah, now let's see. Let us give the same list here as well. We have run this sort list. Yeah, let us check whether we are getting the same output or not. Yes, we are getting the same output. 9 12 23 9 12 23 45 47 45 47 65 74 65 74. Yes. Now the fourth topic is matrix multiplication using functions. Unlike the old method of matrix multiplication, solving it with the help of functions is comparatively easier. We have checked that it involves a very big process of calculating the product of two matrices. And now let's make that easier with the help of functions. And this particular approach is called a modular approach. We divide the question we divide the problem into modules. Modules means small parts, and hence we call it as modular approach, which makes the user feel easy to code with. We define a function called initialize matrix. Here dimension stands for here dim stands for dimension. We had initiated, we had created a list, an empty list C. For I in range dimension C dot append, we append an empty list. For I in range dimension, for j in range dimension, because we need to attend zeros for the columns as well, because we cannot leave the columns, we cannot leave the only rows appended. We need to append zeros to the columns as well. And now we return C. We are done with one of the parts, which is also important, but it's only the first part. Now we define the dot product of two lists. Here two lists U and V are also called the vectors. Now the dimension is considered to be length of U, because we consider that the length of U is same as the length of V here, because it's only that we only take we only consider two rows, multiplication of rows and columns even only if they are equal in element numbers, because in other words, as we are dealing with only square matrices, the dimension is same for both U and V. As discussed earlier, we initialize the variable answer is equal to 0. Again, for I in range dimensions, answer is equal to answer plus. Earlier we had taken sum is equal to sum plus the index element present at the ith index. Similarly, we update the value of ANS with the help of dot product, which is element present at ith index of list U and element present at ith index of list V, which are both vectors, and we return the answer to it. Now coming to the row part of the new matrix or new combined list. Dimension is equal to length of M. Here M is a matrix and I is the row of matrix, is one of the rows of matrix, and L is a empty list again for K in range dimension. Because why haven't we considered I here? We haven't considered I because we are defining the I here, and we are in need of I, so we should not consider I inside the loop. Hence we have taken for K in range dimension L dot append. We append the ith row here. And similarly, the similar logic is applicable to column as well. And now we have done all the steps for till here, and we are at the final step, which is matrix multiplication. Here A and B are two matrices. As we are dealing with only square matrices in this particular module, the dimension of length, the dimension of A is the same as the dimension of B, which is square matrix. Either it can be 2 or 2 by 2 or 3 by 3 or n by n. In a standard format, n by n. C is equal to initialize matrix dimension. And all over we go again to the first definition part, and yes, that is called here, and all the internal process takes place for I in range, for j in range, for defining both rows and columns for the new ones, for defining both rows and columns for the new matrix, we take Ci Cj is equal to dot product. We call the function dot product, which gives us the value of answer, that is, which gives us the first element or the first entry. In the similar fashion, we get all the entries here. Dot product of row Ai, column Bj, and that's it. This is all about matrix multiplication using the help of functions, and this entire process is called as a modular approach. Please make note of this, students. And now recursion. What is recursion? Recursion is simply referred to as repetition of a particular step. Python also accepts function recursion, which means a defined function can call itself internally. Internally means inside the loop as well. Recursion is a common mathematical and programming concept. It means that a function calls itself. This has the benefit of meaning that you can loop through data to reach a result, that is, to get up a desired result. A typical example of recursion would be, this is just a basic example. Define fact, which stands for factorial of n, if n is equal to 0. We are just checking if the value of n is 0. This isn't an assignment operator, but this is used for verifying the value. If n is 0, we return 1 because the factorial of 0 is 1. If it isn't 0, then we do this. This is where recursion happens, because we had defined factorial here, and again the same function is being used here as well. Return n into factorial of n minus 1, and this same concept is applicable until the value of n reaches 0. Yes, and now let us check. N is equal to 5, fact of 5, 120. Yes, that's right. When should we use functions? Or when to use recursion? When a problem can be divided into steps to make it easier, then we need to use recursion. This is the first rule. The result of one step can be used in the previous step. That's the second condition. There is a scenario when you can stop subdividing the problem into steps and return to a previous step. This is the third function, or the third condition. The fourth one is all of the results together solve the problem. If the four conditions are met, or if we find any of these four, we can directly proceed to recursion. And now let's get into types of arguments. The first type of argument is positional argument. All functions that you have seen so far are positional arguments. You see, all of these come under positional arguments. Here, the position of an argument in the function call determines the parameter to which it is used. Upon hovering means like doing this. The position is highlighted in the definition part. The second type of argument is that keyword arguments. The keyword arguments introduce more flexibility while passing arguments. This is different from positional arguments, where the position of argument in the function call determines the parameter to which it is bound. One advantage of using keyword argument is that it reduces the possibility of entering the arguments in an incorrect order. This is just related to conceptual knowledge, but an important point to be noted is that when we do not give the same number of arguments that are declared in the define section, like in the earlier we had given matrix multiplication a comma b, and if we do not give the values of both a and b, it throws us an error stating positional argument b is missing, and if we only give a. And now let's move on to scope of variables. Scope of variables. There are two kinds of variables, local and global. Whenever a variable is assigned a value anywhere within a function, its scope becomes local to that function. In other words, whenever a variable appears on the left side of an assignment statement anywhere within a function, it becomes a local variable. Global. What is a global variable? If a variable is only referenced inside a function and is never assigned a value to it, it's implicitly treated as a global value. This is the first example. We see that y is present above calling the function, and here y is below after calling the function, but the result is same. This is the reason. Notice the difference between this code and the one at the beginning of the earlier section, this and this. Here the variable y is defined after the function definition, yes, while in the earlier version y was defined before the function definition. All that matters is for y to be defined before the function call. Global. What is the use of global keyword? Global keyword is a keyword that allows a user to modify a variable outside of the current scope. It is used to create global variables from a non-global scope, that is inside a function. Rules of global keyword. We had provided that in the notes given link below. And please refer the notes that has been put up, and please refer the note that has been put down in the link below to get a better understanding of the fifth week. It covers all the important points of the fifth week. So please take care that you keep revising that as many times as possible. And I thank you all for watching this video. Stay safe, stay healthy, all the best.